Hello everyone, this is Roy. Welcome back. In this video, we are gonna discuss about another project. In previous session, you saw us doing a project on Python and doing the exploratory analysis. But in this video, we are gonna do the data analysis. I mean, it is actually the remotely sensed data, that is satellite data. We are gonna analyze the satellite data to look for something. So what we are looking for in this video is the land use and land cover change. In this video, we will discuss about the land use and land cover change in a in a specific zone. So the zone that is selected for us is Calcasieu. That is a part or a county in Louisiana. So what we are looking for in this project, that we are going to take 4 different decades, and we will gather the satellite data, and we will do some process and create an image of land use and land cover. So and then for every decade, we are going to analyze if the land use or the land cover has been changed in different decades. I mean, from 1983 to 2023, what's the change in land use and land cover we are going to determine through this study. So first of all, we need to take the data. We need to take the data from a specific site that we got our shape files from. LA Department of Transportation, and how we downloaded and how we do the pre-process. My friend is gonna explain now.
So, after downloading the Louisiana Parish shapefile from Louisiana Department of Transportation and Development and unzipping it, go to QGIS, and from the browser panel, trial 1 folder. From parish folder, we have to import the parish boundary shapefile to the layer panel. So this will show us a map looking like this. Now, from the processing toolbox, search extract by expression. Double click on extract by expression. And now select this E button right next to expression. And from this menu, select fields and values. And from this menu, double click on parish name and select equal to sign. Then select only unique. Then we will see the name of parishes of Louisiana states. And from this menu, double click on Calcasieu. And this will get us an equation looking like this: parish name equal to Calcasieu. Then select OK. Then select run. After it ran, we will close this window. Now we can see the Calcasieu Parish boundary on the map of Louisiana state. Now we have to save this scratch layer by clicking the scratch button right next to matching feature. Then we have to select the name in which file name in which we want to save this file. So I'm selecting the Calcasieu folder under trial 1 folder and naming my file as Calcasieu and save it. And the format is S3 shapefile. Then we click OK. The scratch layer has been saved. Yeah, the scratch layer has already been saved. Now we just remove these layers. Now we will import the CalCashew shapefile here in the layers panel, and we'll go to the process toolbox and search by extract. By extract, we'll select the extract by layer, extract layer extent, double click on it, and we'll select this button here right next to extend and select save to file. Then we will select the file CalCashew extend under the, we'll select the CalCashew extend folder under the trial one folder. Then name the file name as CalCashew extend and save it, and then we'll run it. After it ran, we'll just close the window. This will get us a rectangle like this. Now we'll double click on CalCashew extend and turn this hollow outline red and click OK. So we will see an extent of this map, and the reason we have done it is that the Path Explorer cannot map more than 500 points to capture the outline of our area of interest, which is Calcasieu Parish, County of Louisiana State. And that is why we have just created an extent shapefile to capture the extent of our AOI, which is a rectangle with 4 bounding coordinates around the Calcasieu Parish or our area of interest. Now we will go to the file where it has been saved. Now we'll select all these CalCashew extent files and compress it to a zip file for uploading it on Path Explorer for getting the data we want to download from Path Explorer.
Hello. After completing the shapefile extend in USGS Art Explorer, then I have to go to data range and then select the search from option to select the decades. And I'm here selecting the decades of 1984, January 1st to (1993) December 31. And then the cloud cover is 5% because we're using the Landsat data. And then I have to go to the data sets, Landsat data, and Landsat US Analysis Ready Data ARD. I have to select the ARD data, then results. After that, we have to select the SWOT position of this extended area. So now I have to select the best option. Which picture is best or not, you can see from the left side vertical bar. And select the picture option. Is it covering the area or not. This might work. And this one. So here we can see that the whole area is covering by the SWOT, two SWOT, and we are mosaicing it actually. And the mosaicing is to actually the two layer have to merge the extended area that which will cover the full area. Then you can download the data. This is the download option, and then we have to go second one. Air data is surface reflection reflectance model. So after completing the USGS Earth Explorer data, we have to open the QGIS, and then I have to upload the Calcatio shape file. Then I have to reproject it. So to reproject, in the processing toolbox, I have to search for reproject layer. Then my input layer will be the Calcatio shape file, and my target layer should be Albert equal area A. And then we have to save the file. I'm creating a new folder in here. Calcatio A. Then the file name Calcatio A. And we have to save it in the geopackaging format, and it's saved. And then we have to run and close it. So you can see that there is a Calcatio AEA file is created in here. So you can remove the remaining layers here. And after that, I have to upload all the band files which we have downloaded from the Art Explorer. As we have two SWOT, so we have to upload all the files in here. And the second person, I have to remove this layer, a geopackage layer at the top. Now you can see the whole area, and you can see the properties, and the source is Albert equal area, which is our target layer. You can see our band is also in the L vertical area. So now we have to go to clip the raster clip, clip raster by mask layer. And we can do it run as a batch process. So I'm selecting the first file data source in here, v1, v2, v3, v4, band 5, and band 7. And our mask layer should be calculation AA. And everything should remain the same. And the mass extent should be low. And now the clip mask in here, you have to select, you have to create a folder called a show clip. I'm actually doing for project, so I'm doing it for project, and then I'm saving it as band 1, save, and you have to fill with numbers, and it will create the numbers. And now we'll run this project. Now it's close. Now we can see if this clip file is created or not. Visual Clip project. Now you can see that all the band file is created in here.
So now we have to do the same. We have to do the same process for the second batch of the downloaded Landsat images by selecting clip raster by mask layer and then select run as batch process. Then we have to add the band images here by selecting from this menu. We are selecting the band surface reflectance band 1. Then we will click this green plus button and then add the SR band 2. Then we'll add SR band 3, and just like this up to band 4, 5, and band 7. Then from this mask layer column, we have to select the reprojected shapefile and fill down. This will fill the whole column. And for this column, match the extent of the clipped raster to the extent of the mask layer. We have to turn this yes to no. Then select fill down. Thus, this whole column will turn no. And from this clipped mask column, we have to select the file where we want to save all these band images. So I'm selecting the clipped CalCache folder and naming the file band name as band2 and save it. Then selecting select numbers, then select OK. So the band's name will be named by like band 21, 22, 23, 24 up to 27. And after this, we select run. Now it's running. After it ran, select close. So here we can see in the folder the files or band images of named band 21, 22, 23, 24, 25, 26, and 27 have been created. Then we have to now we will remove all these existing bands in the layers in the layer panel. Remove layer, and we will import this band 1, 1, band 1, 2, band 1, 3, band 1, 4, band 1, 6, 7 up to band 2, 7 here in the layer panel. Okay. Now yeah, all these files have been imported here. Now we will go to raster, select miscellaneous, then select merge, then we'll select run as batch process. Okay. Oops. Yeah. Raster, miscellaneous, merge. Then we will select button and select band 1 and band 2, 1. Then select OK. Then we'll set these values to 0. And from this merge, we will select save to file. So as the file folder, we will select the merge bands folder to save all these merge bands under trial 1 folder and name this file name as band 1 and save it. And we will run this. Run. We will close it. So it now in the layer panel, it's showing as band 1. So the merged bands for band 1 and band 2 have already been created as band 1, and we'll do the same process for band 1 2 and pair it with band 2 hit OK, turn this value to 0, then select save to file. The file have already been selected, merged bands, and we will name the file as band 2 and save. Then we will run this. So it ran. Now we will close it. So the band 2 have been created, and we will do the same process for band 1 3 and pair it with band 2 3, and band 1 4 pair it with band 2 4, and up to band 1 7 and pair it with band 2 7. Now we are actually here, we're merging the band 1 images of the 2 downloaded Landsat image data, and we will do the same for all the 7 bands. Like we'll merge the band 1 2 with band 2 2, and band 1 3 with band 2 3, and up to band 1 7 to band 2 7. Once we complete these 70 files will be created in the merged band folder. Will be created in the merged band folder. So after completing all these merging steps, if we go to the merged bands folder, we can see that 70 files have been created in this merged bands folder, namely band 1, band 2, band 3, band 4, up to band 7. Now we have to paste this reprojected geopackage file to this merged bands folder, because we are going to use this merged band folder as the working directory in R for our exploratory data analysis.
Well, after completing the QGIS part, we have to go to the R Studio. And in R Studio, the first step is to write the name and the libraries. So here we can use some library data which we have to install in R. So in here you can see that the library Terra stands for main workhorse, and GData is useful for data manipulation, chord plot, plot of correlation. So every library is working individually. Now in step 2, well, you can run all the libraries. It's already installed. Now in step 2, we have to set the working directory, which is very important. And we're using the merge folder. You can see the merge folder Here we have the 6 bands in here, and I have to just copy this path and have to paste in here. And then in state 3, I have to write all the bands, which is aerosol, blue, green, red, and it's a true. Actually, we have 6 bands in my ticket, so I'm removing shortwave infrared 1, and its C stands for vector. We can run. It's running. After that, in the stage 4, have name calcatio geo package. You have to work with the geo package file and then plot the calcatio, which is short form is cal.
Now at step 5, we want to crop the band images. Cropping means cut the sides of the images, whereas masking doesn't cut the images, it just erases the outer sides of an image. So the codes at step 5 will crop the image data. So if we run this, so we have to select everything from the start and then run it. It ran, and this code will take the band images sequentially one by one and then crop it. And at step 6, if we run the code at step 6, it will run it. It will create a GeoTIFF file of all bands in the working directory. If we go to the working directory, we will see that a GeoTIFF file named cal all band 14 to 23, a GeoTIFF file have been created. Now we have to import this GeoTIFF file of all bands to the layer panel of QGIS, and we will get an image looking like this.